Hi guys, here are the answers to your Flipgrid summative. I figured I would just do a video and go through everything, and that way you would have all the correct answers to this summative grade, and you could use this as a study tool if you wanted to. All right, so number one, you're looking for the velocity and the acceleration. So your velocity is going to be the first derivative of the position function. So you should get 6t squared minus 30t plus 36. Your acceleration is the derivative of the velocity, which is 12t minus 30. For part B, you're asked to find the average velocity. So that's going to be x of b over x of b minus x of a all over b minus a. It was on the interval from 2 to 4, so that comes out to be 10 minus 6 all over 4 minus 2, which is 2 units per unit of time. Letter C, the particle's instantaneous velocity at t equals 3 is your derivative. Evaluated at 3, plug the 3 in, and that comes out to be 0 units per unit of time. When is the particle at rest? Well, the particle is at rest when the velocity equals 0. So you set your velocity function equal to 0. It's a quadratic, so you can just factor it. We get 2 times at t equals 3 and at t equals 2. Now, when is the particle moving to the right? Well, we know velocity controls direction. So when your velocity is greater than 0, you are moving either to the right or up. So I put down 2 and 3, and I also put the endpoints 0 and 5, and then I tested some points in between each one of these intervals to see if my velocity would end up being a positive number or a negative number. Between 0 and 2, it's positive, and also between 3 and 5. So the particle is moving to the right on those 2 intervals. Now, total distance. This one was commonly missed. So I want to show you how to do this one so that it's kind of easy for you. So total distance is needing to use the position function. So we are given the position function, and I have that graphed over here using Desmos. So let's see, maybe I can make this a little bit larger for us. Okay, so here's your position function, all right? Now, what I want y'all to notice is that the initial position for this particular particle is way down here at negative 22, okay? Because that is the y value at 0. If I were to plug 0 in to my position function, the answer that I would get is negative 2, and that gives you the initial position. So position function gives you position, and then you can calculate distance from there. So we're starting out way down here at negative 22. And over time, the position is changing and moving all the way up to 0. So that's a movement of 22 units to begin with. So if I write that down to keep track, we got 22 units so far. Now, we're still moving because we're on the interval from 0 to 5. So I got to go all the way to 5 units. Now, up here, we get all the way up to 6. And then the position changes and he goes back. So, but we do get all the way to 6. So from 0 all the way up here is another 6 units. So I could put plus 6 like that. Now, looks like we turned around and we went back. So this is in line with 5, okay? But we're doing total distance. So that means even though we turned around, we still count that 1 unit that we did. Now we're here at 5 and we're going again. So we go all the way up till we get to x equals 5. So I'm going to have to be careful here and watch what my points turn into. I'm not at x equals 5 yet. Almost there, getting there, still going. Still going. There we go. It's like up here, I think, right? Yeah, right about here. So we get, okay, at 5, if I can get right on it, we go all the way up to 33, okay? And that positive 33 is the last position. Like that's where the particle ends its journey at 33. So we were all the way down here at 5. So from 5 all the way up to 33 is another 28 units. So if you go from 5 to 33, that's going to be a difference of 28 units. So when you add all of these up, you end up getting a total of 57 units. So that's how you do total distance. Now, I know there's formulas that you are given that it's the distance between turning points, and that's exactly what we just did. We did the distance to this turning point, and then the distance from this turning point to the next turning point, and then the distance from the last turning point all the way up till you get to the last y value on the given interval. But you can figure this out. You just need to use that position function. And perhaps we just need to do that a little bit more in class so that way y'all remember that it's not too bad. Okay, letter G, maximum velocity. So maximum velocity is going to be the highest that your velocity graph gets. So you could graph your velocity because you did calculate what it was. Let me put it in here for you. So minus 30x plus 36. There's your velocity graph. And remember, we are on the interval from 0 to 5. So you just need to find the highest point that this graph gets between 0 and 5. So it's a parabola. So I would imagine that the highest point is going to be at the end points. And looks like it's going to be up here. So if you get to 5, right at 5, the y value is 36. So your maximum velocity is going to be 36. So what I just graphed my velocity function and I looked for the highest point on it. That's one of the easier ways to do that one. Okay, now letter H. This one also was commonly missed, and I understand your thinking completely, but you got to pay close attention to where you are, right? So the question was, is the particle moving towards or away from the origin at t equals 1? And so a lot of you found the velocity at 1, which turned out to be a positive number. And so if velocity is positive, that means we are moving to the right. The problem is that this position, this little particle, didn't start at the origin. This particle started way down at negative 22. So you got to pay attention to where you are, and then from there, use the right and the left direction. So we started at negative 22, that was the position. And so if we're moving to the right from negative 22, we actually are moving towards the origin. So I think I gotcha on that one. So just be careful, take into consideration where you start, and that position function will help you with that information. Letter I, is the particle speeding up or slowing down? We did a nice job on this. Remember that if the velocity and the acceleration have opposite signs, then it's slowing down. So you'd plug 1 in for the velocity, you'd plug 1 in for the acceleration, see what you get as far as positive and negative answers, and then go from there. If they're both positive or they're both negative for that matter, it's speeding up. Letter J, what's the displacement? Displacement is just a formula, so x of 5 minus x of 0, and total displacement is 55 units. Okay, that's number 1. For number 2, you're given another position function, a whole lot more complicated than the original one, and you're asked to find the velocity. So when you do the velocity for this, everybody, you've got to use product rule, okay? Unless you chose to like multiply it all out and then after you multiplied it out, use power rule. You could do that too. That'd be a pain with a cubic, but you could do that. But you got to use product rule. Some of you did not use product rule and then it kind of like messed up the rest of your answers. So you're going to take the derivative with chain rule of the first part times the second function plus the derivative of the second function, which is 1 times the derivative, times the original function. I just left mine like this. Those of you that were brave and multiplied it all out, that was awesome. But you really don't have to. Don't worry about that, you guys. Just this is fine, okay? Part B, when does the particle stop? So you would set this equation equal to 0 and or check it with a graph. I think I have the graph on Desmos right here. So on the graph, you would find where it touches the x-axis or crosses the x-axis. I think it's, exactly at 2 and exactly at 5. So particle is stopped or at rest at those 2 points. Letter C, does the particle change direction at all of its stops? Now, this is where the graph is super helpful. If the particle stops and changes direction, it's going to change direction when the velocity graph, which is what we're looking at, changes sign. So here, the y values are all negative. And then we get to 2, and then on the other side of 2, they're still negative. So at t equals 2, the particle did not change direction. Now, at t equals 5, remember, this is a velocity graph. You are looking at velocity, not position. Down here, the velocity values are negative. Now they're positive. So since the graph changed from negative y values to positive y values, the particle changed direction. So it only changes direction at t equals 5. Letter D is asking you displacement. So that you're just going to plug right in. We get -5 units. Letter E is asking you total distance. So I would use the position graph for this. Okay, so here's your position graph. We're going from 1 to 6. So from t equals 1. So at t equals 1, we are at, where are we at 1? There we are, right about here. We're at 5. Okay, so at t equals 1, we start at a position of 5. Okay, we keep going and we get all the way down to the x-axis. So we've moved 5 units so far. Okay, so I could keep track of this. So I moved 5 units. Now I'm still going down. This graph is going to dip pretty far down here. It's going to go all the way down to -27. So the position has changed from being here at the x-axis, which is 0, a y value of 0, all the way down to -27, okay? So don't put -27, put +27 because we're thinking total distance, okay? So we moved another 27 units. Now we come back up to the x-axis. We're up another 27 units to get to the x-axis, so that would be +27 again. And then that's where we end. Actually, we end. I don't need another plus sign because our interval ended at 6 and I'm at 6, 0 when I'm on the x-axis. So if you do 27 plus 27 plus 5, that's going to equal a total distance of 59 units. Okay, so use that position function and keep track of the y values. For letter F, that was the final one for this, and this ties it into actually what we're learning now, which is mean value theorem, although you did not have to say mean value theorem because we had not learned it yet when I assigned this, but you needed to set the instantaneous velocity, which is this, equal to the average velocity. Now, they did give you an interval. So your average velocity on the interval from 1 to 6, that could be calculated. And I wanted to see you calculate it. That's why I gave you that interval. So you needed to plug the numbers in and get -1. And then you could leave it just like that. So overall, nice job. A few mistakes here and there, like a few little math errors here and there. If you had any major understanding errors, like big time conceptual answers or conceptual understanding questions for me, please don't hesitate to reach out. Ask me a whole bunch of questions. That's why I'm here for you. I hope this helps, and have a great break.